Testing 1, 2. All good. Should be starting shortly. Cool. So that's all good? All good? Cool. Yeah, I guess we can, let me just mute my phone and we can start. Cool. Good afternoon. Thanks for coming. Hope you guys are enjoying the day. This is going to be an intro to hardware, Arduinos and ESPs. So let me just give you, what's the definition of hardware in terms of this talk? As is mentioned in the title, Arduinos and ESPs. It's a bit more about like electronics, connecting components together to build a system, and involves a bit of electricity. So there needs to be a bit of caution. It's not really too much, but yeah, I think it just always be good to be wary when dealing with electricity. So this session is going to be a quick, relatively quick, maybe 20 minutes talk. And after that, it's hands-on. I've got some hardware in the back that we can play around with. And yeah, just free open session for learning. So my introduction to all like electronics and stuff is that I've had some background in playing around with hardware. In university, I did some electronics. We even built like a remote control boat. After that, in working life, I bought an Arduino kit. I bought a Raspberry Pi, but it mostly gathered dust. It was just like, oh, let me just play around with a little bit here and there. No real active projects. And it gathered dust for many, many years. But things change, starting with kids who went to some robotics class and going to the arcades, so physical arcade games. And it got me thinking about like building what it's possible to build in what you can be possibly built, as opposed to kids going to the arcade, because most of the games like this is what physical objects hitting a switch, scoring points. So for those physically seen here, I've actually built this kind of like a whack-a-mole system where it essentially lights up lights, which are buttons which you can press. That's still in a prototyping phase. So it's just one of the things that has got me interested in to see what's possible with all this. I've also got like a cabin office, which is ended up being hot and humid in the noontime. And I'm like, okay, could I do here to like possibly monitor the humidity, the temperature, just to see, okay, how best to exhaust the heat and things like that. But after I got aircon, the need for wanting to do that has withered a bit. But it's still interesting to see what the possibilities are. I've also got another thing in the back where I've got a temperature sensor, humidity sensor hooked up to a LCD, so you can see what the current readings are. And it's hooked up with an ESP with Wi-Fi. We'll cover an ESP later. Yeah, so I'm still learning a lot of things as I delve in and play around with things, but hope that this guides can be like a quick start to anybody new to it, or just things that you can play around with later. So some things to know when dealing with this hardware are things like the CPU or the brain of the system, how are you going to power it, the pins and components, what can it connect to, what does it have, programming the software, right? Because at the end of the day, you want it to do something, it doesn't know how to do it, you got to tell it how to do it. So let's go through some terminology. One thing you'll hear when dealing with electronics is the term microcontroller. So essentially, it's like definition I found on Wikipedia, places like that. It's like a CPU, central processing unit, memory, I/O, input/output integrated into one chip. Sometimes you might say an MCU, microcontroller unit. This is typically for embedded devices because I guess it's simple, reusable that you can program easily. You can hear the term AVR, and this is typically used in Arduino systems that use 80 mega chips. You have the term microprocessor that you might have heard previous, which is usually like CPU, memory, and I/O components are connected externally. Typically, this is what you refer to when you talk about your regular PCs. So when dealing with this, you usually talk about full operating systems. You have ARM that you have with Qualcomm Snapdragon, Apple's A and M processors, a Raspberry Pi with Cortex. You have x86, which is related to Intel and AMD with their appropriate CPUs. Hey, next, Arduinos and clones. So yeah, microcontrollers don't typically come alone. Yeah. Microcontrollers don't typically come alone. They don't come as the chip itself, right? They're usually connected to things, development boards with ability to power it, pins so that it can be connected to things. It might come with sensors and some other niceties depending on what they want to build and how much they want to sell it for. So on the right here, you can see this is a typical Arduino. It's a Uno R3. It's got a couple of things that we'll go through later. Arduino is one of the names that you hear a lot about when dealing with like hardware electronics. I think Arduino technically, their definition is mentioned here, an open source electronics platform based on easy to use hardware and software. Arduino is also the name of the company that builds it. So it can kind of refer to the company as well as the hardware itself. One thing to note, there's going to be a lot of Arduino clones out there. As mentioned, Arduino says they're open source electronics, so they support open source hardware. They even publish the schematics. This allows people to create similar kind of boards to Arduino so that it's compatible with whatever Arduino has. But at the same time, it can be cheaper because they don't have to do the hardware costs. They can just copy what's out there and produce it appropriately. And also with more functionality. So it's also compatible with Arduino software. So on the right here, you have a Mako Uno that we'll have in the back that you guys can play with. As you can see, it's similar in terms of like, the pins on the left, pins on the right, but it's got some extra niceties, I think like buzzers, buttons that the Arduino itself may not fully come with. Next, ESPs. I first heard this term when talking to a friend in Singapore who was way into hardware when dealing with like home automation. And I found that there were some available online as well. So ESPs actually represents the Expressive Systems, semiconductor company, particularly known for the ESP8266 and ESP32 line series of chips. So they claim, I guess, part of the claim to fame, from my knowledge, is essentially they have Wi-Fi, I think Bluetooth as well, so they can be easily integrated into like IoT systems or home automation in that kind of fashion without having extra things. I believe with Arduino, there's some with Wi-Fi now, but from what I've gathered in the short time, ESP is usually there for Wi-Fi built in without too much issues. And it's also relatively cheap. So this is a ESP, one of the ESP boards. So moving along, power. How do you power the board? Some of the things that you need to know is also voltage and current. For anybody who's done physics, you'll see an equation later that you might be familiar with. But yeah, essentially, when you get a board, it's got to be powered somehow, right? Whether it's by USB, this is an old, I think, is it a USB-B cable? There's also a DC barrel for this guy. So possibilities is also, could you actually power something via solar? Because a lot of these electronics, they don't use that much power, so that maybe you just need a solar panel if it's sufficient for, depending on what your use case is. Like for instance, my cabin, right, being hot, it's hot because the sun is up. So if I just have a fan connected to a solar panel so that the exhaust fan gets the heat out, we don't need anything much. If it goes on and off, don't need to worry too much. So yeah, it's just depending on the possibilities. Some things you also need to note is the voltages when dealing with electronics. The typical values you'll see here is like 3.3 volts. Example, Raspberry Pi's GPIO pins are at that value. 5 volts, example, USB inputs typically have 5 volts. I guess now with USB-C, you can go higher, but I guess these are the typical values you'll see. So this is the equation I was talking about. Power is equal to current times voltage for anybody who's used to physics, that you might need to take into account when dealing with this. For instance, if a board says, oh, this is the current value, this is the voltage, what might be the power source that you might need in order to power the board effectively without having weird issues. Do note that there's also current limits per pin. So example here, 20 milliamps and 50 milliamps on 2 different pins. When I was playing around with this whack-a-mole thing, I was just like playing around, hooking things up, these buttons are actually, I think, rated for 12 volts. I hooked them up directly to my board, And I was like, what's that smell? I smell something going on. And it was connected to my computer. And then the computer said, this device is drawing too much current and it's shutting off. And like, okay. So yeah, definitely be wary. I think it was shutting off. So in a sense, it saved the chip. The chip still works to the best of my knowledge. But I did like, what's that smell? Okay, so you got to be wary of how you connect things up. So even like things like current limiting resistors for LEDs, this is something that people say that typically sometimes you see like cheap electronic devices, they have the batteries and they're straight away connected to LEDs. That's not best practice because that means it can draw a lot of current and then it can easily burn out the LED itself. I don't know whether it's, I don't know how long the longevity might be affected for it, but yeah, there's something to note about how best to use LEDs with a resistor to limit the current. And also, there are 10 ways to destroy an Arduino. So I can give you a link to these slides, so you can read about this. There's just things that you should know about to be wary about. Next, let's go to the pins and components of these devices. So pins, as you see here on this Maker Uno on the left and on the right, and right at the bottom as well. So they can be input pins or output pins. So input pins, for instance, if you're reading like a button press, if you're reading sensors, output if you want an output to LEDs, if you want an output to a LCD screen. These can be digital or analog pins. So digital will be essentially be reading or writing zeros and ones. Analogs will be more discrete values in between. And thus a pin can do many things. Like for instance, this is an ESP. You see those pins, they have several modes or several things that they can be done. And it depends on how you set it up in code. So this is where it's important to check the docs or data sheets. And a pin may not work all the time because depending on the situation, like this, I read this is like, oh, this cannot be used when Wi-Fi is enabled. I'm like, oh, that's interesting. So once again, check the docs and data sheets because things may not be working the way you expect it, but it is the way it's supposed to be based on its design. And also, yeah, components, as you see on the right here, this is a Maker Uno. It's got buttons up there. It's got some LEDs on the right. And that's a buzzer speaker. And with ESPs, you've got Wi-Fi and things like that. So there can be different components on a board. And obviously, you can also connect your own. Next, programming the software. You want to connect everything up. It's got to do something. How do you program it? What language do you use? It'll depend on the system that you've picked. Typically with Arduino, it's a C++, I think C++ language or based on that. There are other languages that you can get, Lua, MicroPython. I think MicroPython is also available in some Arduinos. So once again, just check what your device supports and see what you can do. For those devices like Raspberry Pi that run full operating systems like Linux, you kind of have endless possibilities of what you want to run just because it is a full OS. Pick what you want to use. Next, Arduino IDE is essentially the integrated developer environment used for Arduinos. You can download it there. You can even use it from the browser. I haven't personally tried that, but I'm just wondering, I believe they say you can just download some small agent software so that you can actually program things via the browser. I guess it's more catered for like people like Chromebooks. And for those, I think with Android phones, there's even an Arduino Droid app that you can use your phone to program Arduino. So you don't even need a full-fledged computer to get working with this. So for those who are not familiar with Arduino code, I think Arduino programs are typically called sketches. There are two components. The setup, as the name implies, is how you set things up to run the device. So it runs once on boot or reset of the device. And then you have the loop, which continually runs over and over and over again. So that's where your main logic will go to. And this is a simple program of, what's that? Setting the pin mode to a pin have an output. So say, okay, this pin is an output pin. And in the loop is saying, okay, switch it on high. So the light's on. Wait 1 second, switch it off. So it's essentially just blinking a light for 1 second. Other things to take into account. So ESPs, as we mentioned, when I take a look at how to program it, it's so complicated because there seem to be like many different steps to it. But thankfully, the Arduino IDE can come to the rescue because it allows you to add boards to it. So in the settings of the Arduino application, there's a URL to say, okay, what board do you want to support? Got to find the appropriate link to it, and then it downloads the appropriate code to support it, and then connect your device, select your board in the dropdown, and it should be available there for you to choose. Do note if you're having problems uploading, like I was initially, I thought I uploaded a program and then played around, like, okay, things are working. Let me try to update it. It's not loading. Did I break something? What did I do? Is there something I don't know about? This is where it's important to disconnect all the things because, once again, like in the data sheet, there's sometimes it says that some pins must be of certain values in order to program properly. So yeah, I think the easiest thing is disconnect all things, try there, and if it is the case that it works, then yeah, it's probably something like this. That's the issue. So let's talk about components. There's so many components out there, but the typical ones that you'll see, like output components, LEDs, the lights, LCD displays that you can read, speakers. For those into robotics, relays, motors, servos, or more motors, servos, relays more for like home automation, turning things on and off. Inputs, buttons, microphones, sensors, yeah. You have things like input, I guess it's not really a component, but like input, output, Wi-Fi, because you can connect to these things, so you can send an output to something, or you can run a server on the device itself, so that you can use your phone or something to control it via home automation, which is what I guess all the home automation devices are, right? You say on, off, it does what does your bidding. There are other components out there like resistors, breadboards, such as this, and wires, lots and lots of wires when you try to connect things up. Hopefully I have enough wires for you all to play with later. Yeah. Other considerations, expansion boards, Raspberry Pis calls it HAT, hardware attached on top. Arduinos, they call them shields and carriers. Yeah, so I guess essentially it's just like boards that fit on top of whatever you're dealing with. They might have different terminology. Expansion boards, daughter boards, yeah, just extra more components that help you build things. Do note that there can be components that also help you save inputs. So for instance, in the Arduino tutorials, you see that this is how you connect a LCD, a bare LCD to an Arduino. There are other versions of LCDs with an extra daughter board on it, where you only need to connect essentially 2 pins from the Arduino. The rest is just power in order to interact with it, as opposed to the old one was what 6 pins in total. So yeah. When you get new hardware, sometimes it's not supported. This is where libraries can come to your rescue. In the Arduino IDE, just search for things and you're able to download them. One thing that I found is your mileage may vary whether these things work. Maybe it's me being too new to how to set things up and not reading the appropriate docs. Also because the components I bought didn't have any docs. So I'm like, I think this is it. But yeah, I tried several libraries. It didn't work. Then I tried one more. It did. So I'm like, okay, I'm going to use this library. It works. I'm not going to question it right now. So I guess, how do we get hands-on, especially when talking about in our local context of Brunei? Some places that you can buy, Wizon and SmartBit BN are online shops that you can buy. Their turnaround time is pretty fast, actually. I think I ordered things from both of them on last Saturday. Wizon delivered it on Sunday. Sorry, SmartBit delivered it on Sunday. Wizon, I think, delivered it on Monday. So quick enough. If you need to actually go to physical location, I guess some things, Happy Star, they've got a couple of things. Conleong Electronics, Guan Hock Lee might have a couple of things as well that would be useful. Another place online I've heard people buy is SG Robotics. I'm pretty sure there's also a lot of other places online. I've also personally used AliExpress without too much issue. Obviously, postage, postal time will take something you might need to take into account. But I guess, if it's cheap enough, you're like, oh yeah, it's a good deal, especially compared to the in-person places. Like I just bought some breadboards at Con and Leong Electronics. I think it was more than 2x the cost of what SmartBit and Wizon charged. So I'm like, okay. I'm pretty sure you can get it much cheaper in AliExpress, but it is. It is what it is. And also beware of dead on arrival components. I think I've had some components both from Wizon and SmartBit that I didn't test when I got them. After a while, I'm like, okay, let me just try use them. I'm like, it doesn't work. I guess it's dead. Um, yeah, I haven't tried to ask for a refund. It was quite a while back, so I'm like, it's okay for now. It didn't cost that much. But yeah, that's I guess always something to worry about when buying anywhere. Such that that's why physical places are good. But also, whenever you get something, I guess test them, and hopefully, if you buy something new, they're happily enough to refund you or do something. For those of you who are not here to play around with the hardware later, or those who don't have hardwares, there are apparently some simulators online. I haven't personally used them, but yeah, they could be useful to also just learn the basics and see what's possible out there. So yeah, the next steps I would say is that for those who are just not too familiar with all these things, I would say just go play and learn. You might be like me saying like, okay, I know some things about this. I don't have any use of it now, but maybe down the line, yeah, you'll find something for it. Think about IoT or automation possibilities. There are also some IoT, I think, platforms that you can actually use. I think some of these names I saw online, like Blink, ESP Rainmaker, such that you are able to hook in your devices to online systems. You see some YouTube videos, people saying, "Oh, this is how you build home automation with an app as well that you can use to integrate with your things." But yeah, that's all I had for today in terms of like the topics I'm going to cover. Open to any questions. And after this, for those who are available online, in present here, you can play around with some of the hardware that I'll pass around later. Um, yeah, so I'm open to questions if there are any on the floor or online. No questions? Does not seem like there's any questions. That's all good then. If that's the case, I guess we can end it there. What you guys can do first is maybe, where is my slides? Are you able to scan that QR code? This is a link to my slides. Or if you want, let me see if I can update my slides. Or you can just go to let's make this big. Is that? Or there's also just refill.org/talks, and it should be the top linked post. There should be a link to the slides. Yeah, so I'll say there is essentially workshop time, play around. I've got a couple of hardware. Maker Nano, which is a small one, which is what I've got here, this little purple thing. Maker Uno, which is a bit bigger, got some ESPs. So things you could probably do is just go to the Android tutorial, so Arduino tutorials, where Arduino basics and tutorials. Play around, learn, see what you can do, make it blink an LED, read an input, read a button press. We've got light dependent resistors. I've got some temperature sensors as well. Yeah, play around. I guess for those ESPs, you can try to connect to the Wi-Fi and then use your phone to switch an LED on and off and things like that. So yeah, that's all I had for today. Is there somebody going to do the Kahoot? Yeah, I guess, yeah, we can do the Kahoot while I set up the hardware.